Okay, so I'm going to divide this presentation into 3 parts. The first part is to introduce ChromaSense and give you an overview of the group that we belong to. The next part is then related to the line scan vision platform, which is a really cool and innovative approach or platform that we developed, fitting many industries. I will talk about it later in more detail. The third part is related to battery foil inspection as an application, where we will then see the line scan vision platform in action. And what was interesting for us here was to evaluate how deep learning can be used with this specific application, and how it can be hardware accelerated to actually fit the needs of high-speed imaging. So let's start with the company overview. ChromaSense is a machine vision technology provider that was founded in 2004. We belong to the TKH group, and our main focus is related to line scan vision technology. Our business is divided in 2 parts. One half is developing standard products in the line scan domain, like what you can see here on the lower right, cameras and light sources. And the other half of our business is related to vision solution building. Yeah, so a customizing business. So before we move on to the next slide, I want to make sure that everyone here understands the difference between an area camera and a line scan camera. And on the line scan side, it is important to understand that we have a sensor that only contains a single sensor line. And you can acquire a 2-dimensional image by actually scanning the object. So you need a movement between camera and the object that you want to acquire an image from. So here are some applications and markets that we are active in. I will not go into details, but if you have questions, feel free to approach me after this talk. We belong to the TKH group. TKH is a Dutch technology group that is working in 3 technology fields, in smart vision systems, smart manufacturing systems, and smart connectivity systems. And ChromaSense belongs to the TKH vision part of that group, which is part of the smart vision system field in TKH. TKH Vision is a global group of machine vision technology providers, and you see here the brands that belong to this group. And what we have as well in this group is TKH Vision Solutions. And TKH Vision Solutions stands for all the activities that we do related to essentially customizing vision solutions for our customers' needs. So why am I spending so much time introducing this corporate structure? I'm doing that because ChromaSense is additionally operating something that we call the TKH Vision Solution Center. And the TKH Vision Solution Center is an entity that is developing solutions for TKH Vision and for our customers. So I mentioned before that half of our business is related to solution building or to customizing business, and therefore we have a long experience doing that for our customers. So let's move on to the line scan vision platform. So when we developed this platform, we were looking at some trends in the producing industries. And one trend is that the product life cycle of our customers' products get shorter and shorter, and there's a reduced time to market. So there's really a need for flexible machine vision systems. We also see that the quality standards go really up in this domain, and there is a need for faster production speeds. A third trend that we see is that there is a demand for reduced system engineering costs for this kind of systems. So modularity and flexibility are key to being able to provide products that are fitting to our customers' needs. And standardization plays a large role in this. Another aspect that is important here is that we see that the component suppliers more and more offer also additional tooling that allows the customers to be faster on the integration of these kind of components. So we developed this platform for customers that think modular, yeah? And the core components of the line scan vision platform are a modular housing and a camera and light sources, essentially. And you see here on the right side an example of a vision system that is built on this platform. And this is only one example, so the amount of cameras and the type of light sources that are being used here in a modular fashion can be changed, yeah, and we will see some examples later. The flexibility comes with the point that you can change those cameras, so you have different resolutions and different scan speeds that you can realize, and the whole system is very scalable for different applications. The core components are essentially the Alpixa Evo line scan camera family that is offering a wide range of line scan cameras in different resolutions and different speeds, as well as the Corona line light family. And on the Corona line light family, we have all kinds of different light sources that you find in a machine vision application. And light is really key here when it comes to this modular approach. So the reason why light matters can be explained by looking at the spectral properties, for instance, of different illuminations. So the example given here is a banknote inspection. So when you look at the banknote that is shown here on the right side, this is acquired with different light sources, near infrared, ultraviolet, and just a white light. And you can see that different features become visible in the image depending on the lighting scene that you choose. So apart from the spectral properties, you can also have a look at spatial properties. And with spatial properties, I mean the way how you illuminate your sample. So the application example given here is PCB inspection. And you see here on the left side, on the right side, the same PCB just illuminated differently. One time with bright field, which allows you to get an image where it's easy to inspect the substrate and contact pads. And on the right side, you see a dark field illumination that you could use, for instance, for inspecting print markers or find contaminations. So how complex is it to integrate this kind of line scan vision platform? It's essentially very easy because there's only 3 mounting points that you need to integrate into your machine. And then the question would be, how do you align the individual components of this platform? And the way how we solve that is either by delivering to our customers a pre-aligned system, or you can use alignment adapters that are included here for doing this alignment yourself. We also have a specific software that allows you to do a kind of a live adjustment of the system, so you can really do the commissioning in a few minutes. So here are now some examples, but I'm not going really into details. This is a line scan vision platform that is designed for battery electrode foil inspection. There is another example that is for web print quality inspection, and a third one that is for PCB inspection. And really the key here is it's the same modular approach. We just modify the type of cameras and light sources application specific. And there's little engineering time overhead for doing that. So if you have an application in mind, please feel free to come visit us on our booth, and let's talk about configurations that fit your needs. So now the other part of this presentation is related to work that was done partially by 2 of our students that did their master thesis in the domain of battery foil inspection. And the motivation for doing this demonstrator here was that we wanted to see the line scan vision platform in action, and we wanted a tool to acquire real training and test data that can be used for evaluating an AI-based anomaly detection approach in this application. And for the AI-based anomaly detection, what we were really interested in is to see if the performance of these kind of systems fits the needs of line scan imaging with high resolution and high speeds. So we developed a test bench for doing that. So the device that you see here can integrate like 8 meters of continuous battery foil that is then running in circles, let's say. And the application that we considered here was an anode battery foil, but that's not really relevant for now. And the line scan vision platform is the vehicle that you see here on the upper right side. So it contains 3 types of line sources and line scan camera. Now, the AI-based anomaly detection approach that was developed was simply making use of standard tools. So we chose an autoencoder architecture, and this is a CNN-based approach where, explaining it in a nutshell, you have an input image, you have a kind of an encoder stage that is converting your image in a latent space representation, and then you have a decoder that is sort of reconstructing the image back. Yeah? And if an anomaly in your image occurs, like something what we see here now on the left side, you go through the same pipeline, but the output image would then not contain this anomaly. So the identification of an anomaly with this autoencoder approach is being done by measuring the difference between the reconstructed and the input image. And if you have a certain threshold, you will detect it as an anomaly. So that's rather simple. Now, the findings that we had here was that the anomaly detection performance was really, really good. So, of course, we had to stage this because we had to define the defects ourselves, but we had a really high accuracy. However, the speed was on the CPU and GPU implementation not really adequate for what we need in the machine environment. So it was really magnitudes of orders too slow. So there are 2 ways now to handle this. One is you can scale up your hardware in the PC, like using better CPUs and GPUs. And the other way is to look into implementing the whole approach on a FPGA. And this is the path that we followed here. So we made use of Xilinx FPGA from the multiprocessor system on chip family. And this includes a DPU that can be used for deploying those networks that we were talking about. And I really want to make some advertisement here for the Vetis AI tool chain by Xilinx, which is a development platform for which is designed for the AI interference on this FPGA. And I want to make advertisement for that because it is really simple to actually use that without needing the need of a FPGA developer. So we looked at this specific platform because these kind of FPGAs are used in our products, so in the Neo and Evo line scan camera families. And in principle, it's possible to operate it on these kind of cameras. Now I want to walk you through the individual steps that you have to undertake when you want to convert your application onto the FPGA. As I said before, it's rather easy. So the Xilinx tools offer you a model inspector, which is essentially, you feed it with your TensorFlow model that you generated on the CPU side. And essentially, it generates you a graph-based representation of your network. And apart from that, there is sort of an info file being generated that can be used to identify bottlenecks in the implementation that you have there. And in our case, the picture that you see here is this output file. And what we saw here is that the last layer, the activation layer of our network, contained a function that was not supported to be run on a DPU. Yeah? We looked into the details of what was happening here, and essentially you can see here in blue a representation of this function. So the reason is it's a sigmoid activation function which is continuous, and the FPGA cannot compute that in a very efficient way. So to work around this issue, all that had to be done is a linear approximation of this sigmoid function, which is a few lines of code if you know how to do it, let's say. This is the red dotted curve that you can see here. And that essentially removed the bottleneck here. So the next step, also a tool is doing that, is then a model quantization, because the model that you run on the CPU or GPU is a floating point accuracy, and your FPGA is better working on integer, accuracy. And in our case, we did not see really a performance drop by doing this conversion. Then the last step is essentially to compile the model and run it on your FPGA, which is very simple. So we also evaluated the performance of this, and we saw that we get on the anomaly detection performance quite similar results on the FPGA as well as on the CPU and GPU. More interestingly is here to look at the runtime, and this was really the motivation why we did all that. So for simply processing on the CPU, we had a frame rate that was way too low for this application. When doing the native conversion, we have this CPU plus DPU stage, which was already a factor of 20 faster. So it runs on the FPGA, but still uses some CPU computations. And when doing this approximation of the sigmoid function, we could speed it up by a factor of 40 overall. And the really cool thing here is you do not need a VHDL programmer to actually do that. You just need a camera with the right platform and devices AI tools, essentially. So can this now really be deployed on one of our cameras if you just buy it off the shelf? No, it cannot, because the FPGA that we have in there is too small. But it is not very difficult to design a customized camera with a larger FPGA if there is a need for that. So yeah, let's wrap up. Yeah, I was introducing ChromaSense and TKH Vision and our group at the beginning. We can be your partner whenever it comes to yeah, vision components or solutions. We talked about the line scan vision platform, which is really a modular and flexible line scanning rig. And it's designed to reduce engineering time and cost, essentially. And at last, we were talking about battery foil anomaly detection. And we saw that the line scan vision platform can be used here, and that there are actually really nice tools to do hardware acceleration using existing platforms if you have the right FPGA in your camera. So if you want to learn more about that, you can visit us on our booth. It's here in Hall 8. It's very easy to find. It's this large TKH Vision booth. Thanks for your attention.